Good day everyone. In this video we will solve some exercise in lesson 8.5, page 797. Starting with number 42. Given the magnitude of V 2.6, the magnitude of W is 8 and the angle between V and W is 60 degrees, we need to find V dot W. Using the formula cosine theta equals to V dot W over magnitude of V, magnitude of W, we substitute 60 for theta and 2.6 for magnitude of V, 8 for magnitude of W, and then we cross multiply. V dot W will be 10.4. Going to number 50. Number 50. In number 50 we have two vectors, Z 14I plus 7J and T equals to negative 7I minus 14J. The question is, determine if the given vectors are orthogonal, parallel, or linear. We know that if the dot product of two vectors is 0, then the vectors are orthogonal. So let's find the dot product of these two vectors. I will change them to component form. 14, 7, negative 7, negative 14. This is vector. This is vector Z times W. 14 times negative 7 plus 7 times negative 14. Negative 98 plus negative 98 is equal to negative 196, which is not equal to 0. That means not orthogonal. Also, we know that for two vectors to be parallel, suppose vector V and W are parallel, if and only if V equals to C times W, where C is a scalar, C is a constant. So Z and T to be parallel, Z should be equal to C multiplied by T. Or we can find the angle using the formula. Or if you look at the slope of the vector Z is 7 over 4, which is half, while the slope of T is vector T, negative 14 over negative 7, which is 2. They don't have the same slope. That means they are not parallel. Or we can find the angle between them. Let's find the angle between them. We will use the rule cosine theta equals to Z dot T over magnitude of Z times magnitude of T. That means theta equals to cosine inverse of Z dot T over magnitude of Z multiplied by magnitude of T. We already found the dot product of Z dot T, which is negative 196. What's going to be the magnitude of Z? Let's find the magnitude of Z, which is radical 14 squared plus 7 squared, radical 7 radical 5 multiplied by also the magnitude of T, which is the same, radical negative 7 squared plus negative 14 squared, which is 7 radical 5. And let's find the angle between them. Theta using your graphical calculator. Cosine inverse of negative 196 over 7 radical 5 multiplied by 7 radical 5. And the answer is 143.1 degrees. So apparently the two vectors are not parallel nor perpendicular, orthogonal. Second question. Question number 54. 54. In number 54, given vector v equals to negative 8i minus 4j, which is equal to negative 8, negative 4, directly converted to component form. W is negative 6i plus 4j, negative 6, negative 4, positive 4, sorry. Okay, part A. Part A, find the projection of V onto W. Projection of V onto W, applying the rule, it's V dot W over magnitude of W squared times W. V dot W over magnitude of W squared. V dot W, 8 times negative 6 plus negative 4 times 4 over magnitude of W is radical negative 6 squared plus 4 squared, all of it squared, times the dot product times vector W, which is 6 and 4. Okay. Calculation. 8 times negative 4, 8 times negative 6, negative 48. Negative 48, negative 48 minus 16, negative 48 minus 16, negative 64 over radical negative 6 squared plus 4 squared, 2 radical 13 squared, it will be 52. 52 times 6 times W. Now multiply 6 times negative 64, negative 96 over 13, and simple calculation, do it on the calculator. Negative 64 over 13. Okay. Simply multiply negative 64 by 6 and then negative 64 by 4. We will get this vector. This is vector W. This is the projection of V into W, which is V1. We will call it V1. It's the vector which is parallel to W. So I will call this one V1. Part B, find vectors V1 and V2 such that V1 is parallel to W, V2 is orthogonal to W, and V1 plus V2 equals to V. As I mentioned before, the projection of V onto W is the vector which is parallel to W. I will call it V1. V1 is negative 96 over 13, negative 64 over 13. Okay. Okay, now I need to find V2. V2, I know that V2 plus V1 equals to V. That means V2 equals to V minus V1, which is equal to V. What is V given? Negative 8, negative 4 minus V1, negative 96 over 13, negative 64 over 13. Subtracting two vectors, V2 will be equals to negative 8 minus negative 96 over 13. So I'm taking my calculator and trying to do it in the calculator. The answer will be negative 8 over 13, and negative 4 minus negative 64 over 13. Over 13. Okay, I know that V1 and W are parallel. while V2 and W are orthogonal. Okay, so this is V1 and V2, V1 and V2. Going to number 64. 64. Number 64. Find the work done by the given force F acting in the direction from point A to point B. Assume that the units in the coordinate plane are in meters. We have formulas for the work. Okay, the first formula, W equals to F dot D. Okay, the work equals to F dot D if the force is given in vector and the displacement is given as a vector. Okay, we have a second equation for the work. It's the magnitude of the force times magnitude of the displacement times the angle between them. Okay, so F is the force and D represent displacement. So it's very simple. If force was given as a vector and displacement was given as a vector, I use the first formula, first rule. If the force is given, if we have the magnitude of the force and the magnitude of the displacement, we use the second formula. So let's go back to number 64. We have A 17 negative 7, B 27 and 1, and the magnitude of the force equals to 18 newtons. Since we have the magnitude of the force, so definitely I'm going to use this formula. Okay, so definitely I'm going to use this formula. Okay, let's continue. Let's find the displacement. Let's find the displacement. Displacement will be 27 minus 7, 10, and 1 minus 7, 1 minus negative 7, which is 8. That means magnitude of the displacement equals to square root 10 squared plus 8 squared equals to, using your calculator, 2 radical 41. Now let's find what's the angle between them. The angle between them, it's not given. That means the angle is gonna be 0 degrees. They are parallel. Okay, find the work done by the given force F acting in the direction from point A to point B. Assume that the units in the coordinate plane are in meters. So we will assume that they are parallel. So magnitude of F times magnitude of D times cosine theta. So the work will be equals to 18 times 2 radical 41 times cosine 0 degrees. So the work will be 36 radical 41 Newton times meters. Okay, going to number 62. Going to number 62. 68, my bad. 68, I have F equals to 6i plus 3j, so it's given as a vector, 6, 3, and the displacement is also given as a vector, 14i minus 8j, 14 negative 8. So I need to find the work. So directly I use this formula of dot D using the dot product. Okay, 6 times 14 plus 3 times negative 8. 84 plus negative 24, which is 60 newtons times meter. Now the last and final question. Number 72. Number 72. Also, find the work done by a force F in pounds in moving an object in a straight line from point A to point B. Assume that the units in coordinate plane are in feet. So we have A negative 14, negative 20, B 8, negative 35, and we have the force F is given as a vector 40I plus 26J. So I'm going to use this formula F dot D. So we need to find displacement AB, vector AB. Let's find the displacement vector. 8 minus negative 14 is 22, and negative 35 minus negative 20, negative 35 plus 20 is negative 15. So we will find the work 22 negative 15 multiplied by 40, the dot product between the force and the displacement. Okay, let's find it using the calculator. 22 times 40 plus negative 15 times 26, which is equal to 22 times 40, 880, plus negative 15 times 26, which is equal to negative 390. So the answer will be 490, and this is it. This is it. If you have any question, please send an email or contact the administration. Thank you so much.